Hi, welcome to Current Electricity Part 3. Today I'm going to discuss a question. Let's read the question first of all. Find the resistance of a conductor of resistivity rho, mass m, density d, length L and area of cross section A. We are asked to find out the resistance of this. Now we have to discuss different cases of it. So mass and density is introduced here, right? Let me tell you first of all, volume V of the conductor is equal to area into length. Ready? This may be written as mass divided by density. Mass divided by density. A into L is equal to m divided by d. Is it clear to you? Okay. What is the formula for resistance R of the conductor? Rho L by A. Now in this case, what I am going to do is I am going to replace A. That is my first equation for R. Here A into L is equal to m, which means what is A is equal to m divided by LD. Correct? Which means I will write this as rho L divided by, I am substituting m divided by LD. Division means multiplication with the reciprocal, which is equal to rho L into LD divided by m, which will give me the first formula for the resistance. R is equal to rho L square D divided by m. Rho L square D divided by m. This is one formula for resistance. Already this formula you have learned in the previous session. Now this is another formula for the resistance of a conductor in terms of resistivity, length of the conductor, density and mass of the conductor. So this result gives you the resistance R is proportional to L square. R is proportional to L square. Then you may say, sir, R is proportional to L only. No. Now this is applicable. I will discuss the cases where we need to use this formula. Okay, first case. Again I will start with the formula R is equal to rho L by A. Okay. And keeping in mind A into L is equal to m by D, I can say L is equal to m divided by AD. M by AD. Which means rho by A into, substituting for L here, which is m divided by AD. I am getting another formula for resistance. Rho m divided by A square D. Which means the resistance is proportional to 1 by A square. Resistance is proportional to 1 by A square when length is eliminated in terms of mass and density. One more thing I can do is that for circular cross section, A is the area of cross section. For circular cross section, area is equal to pi r square, which implies A is proportional to r square, or resistance in that situation will be proportional to 1 by r raised to 4. 1 by r raised to 4. Now this is an important equation which you need for solving problems. Okay, let us discuss a problem which uses this formula. Now you can solve this, and the question is, a conductor of resistance R is stretched to N times its length. What is its new resistance? This is a question. A conductor of resistance R is stretched to N times its original length. What is the new resistance? Now, which formula we'll use here? If you say R is equal to rho L by A and R directly proportional to L, I will not agree. I will not agree. Why not? I will explain. When a conductor is stretched, the length increases. But volume is equal to area into length. As a result of increasing the length of the conductor, is the volume going to change? Never. Volume is mass by density, right? M by D. Mass of the conductor is a constant, density of the conductor is a constant, which means we can say volume of the conductor is a constant. Neglecting small changes in densities. Okay. Which means when the length of the conductor is increased, area of cross section must decrease. When length of the conductor increases, the area of cross section of the conductor must decrease. So for this kind of problems, this formula is wrong. And this is wrong. In the case of stretching, you cannot use this formula. Okay, I will also explain where I can use this formula. Okay. Now I can say, in this case, I can use the formula R is equal to what? Rho L square D divided by M, or R is directly proportional to L square, which gives me R dash by R is equal to L dash by L the whole square, or R dash by R is equal to L dash is given, it's stretched to N times its length, which means L dash is NL, original length is L, the whole square, this comes out to be N square. Or I will get R dash is equal to N square R. R dash is equal to N square R. Is it clear? Now we can just say a question. A conductor of length L and resistance R is stretched to double its length. What is its new resistance? A conductor of length L and resistance R is stretched to double its length. Then what is its new resistance? What is in this case? Double. N is 2. 2 square. 4. 4R is the answer. Clear? The new resistance will be 4R. Now another question. A conductor of length L and resistance R is stretched to thrice its length. What is the new resistance? What is the new resistance? Your answer. Now you will easily say the answer, right? You can easily say the answer now, because now that becomes a very direct question. It's going to be none or. Similar way, you can try different questions. Now let us discuss another question. A conductor of resistance R is stretched such that its radius becomes 1 by N times. What is its new resistance. So I ask you the question, in this case, which formula you are going to use? Which formula you will use to solve this question? Which formula you will use? Exactly, you are going to use this formula. That is, resistance R is inversely proportional to R raised to 4. Now, what is the information given? So, radius becomes 1 by n times, right? So, in the question, it is given that R dash is equal to R by L. Now we can take capital R dash divided by capital R is equal to small r divided by R dash the whole raised to 4. Right. From this equation I can write R by R dash. R dash I am taking to the denominator n. Okay, I am just exchanging R dash and n. Now R by R dash is n. This is equal to n raised to 4. Or I am getting R dash is equal to n raised to 4 R. This is the answer to this question. Which means a wire is stretched in such a way that its radius becomes half the original. What is the new resistance? Half the original. 1 by 2. 1 by n. In that case, you can use the idea 1 by n is equal to 1 by 2. Then n is equal to 2. 2 raised to 4 is 16. Your new resistance is going to be 16R. Ready? The new resistance is going to be 16R. That's your answer. Okay. Now we have taken two cases. In this case, if I make area instead of its radius, now if I make its area, that becomes the third question. A conductor resistance R is stretched such that its area becomes 1 by n times what is the new resistance. Tell me what identity we have how to use in this problem. Before that, let us write what is given in the question. What is given in the question? A dash. Area becomes, final area is A dash, means A dash is equal to A divided by n. A dash is A divided by n. Now we have to relate between resistance and area in case of stretching, which is R proportional to 1 by A square, or R dash by R is equal to A dash by A the whole square. Allah, A divided by A dash, because they are inverse relation, right? Whole square. Diagonal relationship I used to say. A by A dash the whole square, but what is A by A dash? A by A dash is equal to 1 by n. Allah. It's going to be n. A by A dash is going to be n square, or R dash is equal to n square R. R dash is equal to n square R. So we have taken all three cases pertaining to it. Now the question, where do we use the formula R is equal to rho L by A? That I will discuss by means of another question. Where we will use R is equal to rho L by A. The resistance of a conductor of length L and area A is capital R. What is the resistance of another conductor of the same material of length L dash and area of cross section A dash at the same temperature? at the same temperature. Okay, this is a question. The resistance of a conductor of length L and area A is R. What is the resistance of another conductor of the same material of length L dash and area cross section A dash at the same temperature? This is a question you have to answer. So what is that? What is that here? It's a case of comparison, right? Comparison between two conductors. This is one conductor, this is another conductor. In this case, we will use the formula R is equal to rho L by A. Okay, now let us take. It's given same material, same temperature. Even if same temperature is not mentioned, still as it is same material, you have to understand that rho is same. Why rho is same? Because both are made from the same material. Which means R is proportional to L divided by A. Or R dash by R is equal to L dash by L, because R is directly proportional to L. So R dash by R is L dash by L multiplied by, it's inversely proportional to area, which means A by A dash. I hope this is clear to you. In case of stretching, we will use the formula either R proportional to L square or R proportional to 1 by A square or R proportional to 1 by R raised to 4. And we will use the formula R is equal to rho L by A when it's a comparison between the resistances of two different conductors. I hope the session is clear to you. You can ask your doubts if any. Okay, thank you.